Have you ever tried making a plan with a friend of yours and they say that, okay, we can make a plan. I'm free on Monday and Tuesday. You say that I'm free on Wednesday and Thursday. They said, okay, how about we meet on Friday? And you say, okay, Friday is no good. We can meet on Saturday or Sunday. And you keep on going like this, but you can't able to figure out how to, well, get to a common point, how to find the intersection between your particular schedules. If that is something you faced a problem with in the past, perhaps solving this question can help you out. So in this video, we'll be looking at the question interval list intersections, and you can pause and read the text. What it basically says is that for an input, you've been given two two-dimensional arrays. In each array, each element represents an array of two elements. All right. First would be the start point. Second would be the end point. Points of what exactly? Start point and end point of an interval. All right. That has been given to us as in a visualized manner over here. This is an interval. This is an interval. So start represents the start point of this particular interval. End point represents this point over here for that very interval. And there are one or more of these inside the array, the 2D array, and we've been given two such arrays as an input. What we have to find out is the intersection or the overlap between these two lists of intervals. Alright, so that's basically what's been given to us as an input. And we've been told that each list of intervals is pairwise disjoint and in sorted order. If you find the language confusing, that's perfectly fine. What they simply mean is by pairwise disjoint, they mean that any two intervals within a list, for example, if you're talking about the first list, any two intervals that we can find inside this list, they will not be overlapping with each other. As we can see in this diagram over here, you see that there are no overlaps that exist between these two intervals. They are disjoint, they are isolated, they are independent of each other. And if they are in sorted order, by that they mean that the end point of one interval will always come before the start point of the next interval. And that's pretty much all the information that you need to understand the input that they've given to us. And what they expect in return is the overlap. All right, for that, let's bring this image to the board and talk about it. So I have the image over here. By overlap, they mean, let's say we have this interval in list A and this interval in list B. So their overlap would be something like this, right? All right. So we have some parts of A and some parts of B that make up part of our answer, which would be the points. If I can read properly from here, that would be points 1 and 2. All right. So that's one of the intervals that is found to be at an intersection, as an intersection of these two intervals over here. And you have to do the same for all the intervals in these two lists. So how do we actually approach this problem? We approach this problem by answering four questions. Question number 1. How do we start? So we are going to take a two-pointer approach to solve this question. We take 2 pointers, we keep 1 pointer over at the first element of the first list, we keep the other pointer over at the second element of the second list. Sorry, the first element of the second list. Now, next question is, how do we get the intersection of any two intervals given to us in this manner? Now, the way we can find an intersection is actually quite simple. We have to find 2 points, right? The start point of this intersection and the end point. So I say that the start point of this intersection can be whatever is the highest value between the starting points of these two intervals. So the max of starting point number 1 and starting point number 2, and by implication and by logic, the end point of this interval would be the minimum of the endpoints of the two intervals that we are testing at any given moment. For example, if we look at these two intervals over here at our current pointers, we would see that the starting point is at 0 in list 1 and starting point is at point 1 in list number 2. So the starting point of their intersection, if one exists, that would be at the point that is maximum of the two starting points. So starting point 1 is 0 and then the other one is 1. So the maximum of the two is 1. So I say that that will be the starting point of my intersection, and the end point of my intersection would be the minimum of the two endpoints, that is between 2 and 5. So the minimum would be 2, and that is how we've calculated the interval, that is the intersection of these two intervals given to us. And if you would see over here, that is basically what we are getting as an answer. We've seen the two starting points, we've taken out whichever is the maximum, since we have to calculate the overlap, right? So we have to get the minimum overlapping area, or the overlapping area, so to speak, between the two intervals. And between the two endpoints, the point in the list A becomes before the point in the list B. That is why we have the overlap visualized over here at index number 2. And that is what we've written so far. Now the next question is, well, we may encounter a condition where we don't have any intersections. How do we handle that? The non-intersecting intervals. So I ask, in what conditions do we get a case where an intersection does not exist? An intersection would not exist if the endpoint of the interval that we are currently testing comes before the start point of the other interval. Now, it doesn't matter if list A comes first or list B comes first. We have to handle both cases, right? Because the interval could be in either of the lists, the starting interval, that is. So we have to see if the endpoint comes before the start point of the other interval, an intersection would not exist. And of course, that can happen in a case such as this. Let's say we have this interval being tested with this interval over here in one of the examples, or this interval as the interval that comes before with the interval that comes after in list A. In both cases, we see that there is no intersection, right? There is a difference. So in that case, we will simply check for the endpoint of the starting interval, and we'll see if it comes before the start point of the other interval. So if that happens, the intersection does not exist. In that case, what we will do is whatever is the trailing interval. Let's say we're testing this one and this one over here. Whatever is the trailing interval, the one that is coming before, we will simply move the pointer from this one to the next interval in this list, and then we'll repeat the process. That is basically how we handle non-intersecting intervals. All right. And the next question that I would like to ask is, how do we actually move the pointers forward? So I must ask, which pointer should we move forward after we're done processing, whether it is this case, like in this case in particular. If we found the intersection, how do we test for the next intersection? How do we calculate the next value after, let's say, 1 and 2 over here? So I say that whichever endpoint comes first in either of the lists, we move the pointer from there. Because we see this list over here, this interval over here, and this interval over here. If we move the pointer from this point to this point, it is of very little benefit to us, because this point right here, where the pointer still exists, it cannot possibly make any more intersections with any of the values over here, right? So we don't really need to test this anymore because it has ended right here. But if we move the pointer from this point to this point over here and keep the initial pointer as it is right here, in list 2, we will see that since this point ended first, there's the chance in this area that we will encounter another overlap. There is a possibility, right? I mean, of course, you're seeing this graph and you're saying that, okay, there is very less area, but in other examples, that can very well be the case. In fact, even in this example, if you notice carefully, there is this one line that's coming over here, which is why we are getting this overlap. All right. So what we do is we, in that case, move the pointer because the endpoint of list 1, the current point at list 1 comes before the endpoint of the current point at list 2. So we move this pointer, we test again. All right, we test again. We find the intersection in this manner that we have specified in point 2 here. The maximum of the starting points is 1 because we're testing between 5 and 1 over here. So the maximum of starting points would be 5, sorry. We have 5 over here. Then the minimum of the ending points is between 10 and 5. The minimum is also 5, which is how you get this single line that gives us 5, 5 as our answer. Now, where do we move? That is the simple question to ask. So we move pointers, as we just discussed, from the trailing interval. So where were we currently? We were currently at these 2 points. We were at this point over here and this point over here. So we will move from the trailing pointer. We move this over to the next one. So we have list 2. The pointer goes over to the next interval. All right. We repeat the process between this interval and this interval over here. Right. These are our current intervals where the badly drawn arrows are. And we find the intersection between them. So the maximum that we have between the starting points is between 5 and 8. That gives us 8. And the minimum of the two endpoints is between 10 and 12. That gives us 10. And if you would notice that that is basically what we're given over here. That's 8 and 10, right? It's 8 and that's 10. Now the trailing pointer is over here. This schedule and this interval ends first. So we move the pointer from here, scratch this out. We are now onto this one. All right. Now we test between these two intervals. Now this is an important case because if you would notice, let me just move the arrow first. If you would notice, as I said, we test non-intersecting intervals by means of comparing the end point of the trailing interval to the start point of the interval that is forward. So the end point of this interval is at, well, 12. This is list 2. The end point is at 12. And the start point of the other interval that we're pointing to is at 13. So they don't overlap. 12 comes before 13. There is a gap of 1 in between. So we simply say that there is no intersection that exists. So in that case, as I mentioned, we move the trailing interval forward. Scratch this out. Go over here in list 2, right? So we move this pointer, come down to the interval that starts at 15, ends at 24. Now, do we have an intersection over here? Visually, we can see that we do. But how do we calculate it? We calculate it by getting the maximum of the starting points, that is 15, and the minimum of the starting points, the minimum of the ending points, that is 23. We move again, and this time we move from the one that is ending first, that is the one in list A over here. So we move to the next one, which means we scratch this one out and we are now pointing to this one over here. So between the two of them, do we have an overlap? Which basically means does the endpoint of the interval that comes before, is it overlapping with the start point in any manner? The answer is yes, because the exact point at which this ends and at the exact point at which this starts are the same, which is why we get this as an answer. And that would, of course, fit this formula as well. So the maximum between the starting points of the first two lists is 24, and the minimum between the endpoints would be between 24 and 25. That gives us 24, which is a singular point, as we can visualize onto this graph. Now we move again, and we move from the trailing point, the one that ends first. So we scratch this one out, move on over here, and test it out once again. So we move list 2 forward. All right. So maximum between the two starting points is 25, and the minimum between 25 and 26 is 25 again, and that is the singular point that has been found as an intersection between this interval and this one over here. Now you notice that there are no further intervals to test in list 2, and that is basically when we end the process. Whenever we run out of the intervals in any one of the lists, that is when we end it, because there can't be any more possible intersections. And that is basically how you solve this particular question. In the next video, we will be actually implementing the solution. So stay tuned and follow for more.